Today we look into number base. Yes. Now, number base is just a system of counting natural numbers in bundle. It's a way we used to represent numbers. Yes. Yes. Now, what you need to know is that we have different base. Yes, different base in this number base. Now, the most familiar one I expect you to know by now is base 10. Base 10 is the numbers we learned how to use. Like the money we count, 10,000 naira, $1 million, they are all in base 10. Yes. We humans will always make use of this. We also have the next popular one, I think, is base 2. Base 2. Yeah. Computer language. Computer understands more of base 2. We call it binary. Base 10 is also called binary or decimal. Let's use decimal. That's base 10. Another familiar one is base 8. Base 8, yes. Base 8. Popular also is called octal. Octal. One more popular number base we have is base 16. Base 16. It's called hexadecimal. Hexadecimal. Now, I want to explain something for you now. If we have base 8, first I'll have a base, let's say base B. The numbers involved in base B is going to be from 0 down to B minus 1. Yeah. If I have base B, the numbers, like the digits you will see, the numbers involved in base B is from 0 to B minus 1. Just like in base 10. Numbers involved in base 10 is going to be from 0 to 10 minus 1, that's 9. Numbers involved in base 10 is from 0 to 9. That's why decimal, the numbers we're using today, you can never see anywhere we use number today that's not between 0 to 10, 0 to 9, sorry. So base 2 will start from 0 down to 2 minus 1, that's 1. So numbers involved for base 2, which is binary, is just zeros and ones. Base 8, numbers involved should be from 0 down to what? 7. Yes. 8 minus 1 is what? 7. Here, numbers involved there should be from 0 down to 15. Yes. But 15 is a combination of two numbers. From 10 is a combination of two numbers. So from 10, we will not use these numbers to show them. We shall use alphabet to label them. So we are taking 10 to be A, 11 B, 12 C, 13 D, 14 E, and 15 F. So That's it. For base 16, we'll be having this as these letters to use to show our numbers. Now, what you see most in your exam is not what's digits or what numbers are involved in base 8, 0 to 7. If I ask you now, Sam, if I ask you what numbers are involved in base 5, from 0 to what? 4. Yes. If I give you this thing down, let's say I have 4, 3, 1, 7, and I put here base 5. Is it possible? No, it's not possible because base 5 cannot have 7. The highest number I can find in base 5 is 4, from 0 to 4. So this cannot be in base 5. So I can give you now which of the following is not base 5. Because you know the numbers involved for base 5, you can identify anyone that's not in base 5. Yeah, so far we are saying that if you must be in base 2, if you are in base 2, if I have a number in base 2, it will be something like this: 1 0 1 0 1 1. In base 2, the highest number you can find in base 2 is 1. Yeah, so from 0 to 1. How about this? 1 3 2 1 in base 5. Is it possible? Yes, it's possible. All these numbers here are less than 5. Because they are smaller than 5, it can be in base 5. Next thing we'll learn now is conversions. How to move from one base to the another. Because in the exam, we always ask you to convert from one base to another. Let's learn this. So quickly, I want to show you how to convert from base 10 to binary. That's base 2. It's simple. It's something you should have known already. Alright, let's all have here 25. Convert 25 into base 2. What do? We simply divide with 2. Yeah. So what do we do there? Pause. So let's convert 25 from base 10 down to base 2. Can we? Yes, we can. It's simple. It's something you have learned from your JS3 back in those days. Let me just remind you what you know already. So what do we do here? We'll simply say 25, we'll draw a line, and start dividing by 2, right? Yes, divide by 2. 25 by 2 persons. If 2 persons share 25k, what will they have? They will have, each person will have 12k, and 1k will remain, remainder 1. If they share it again, 2 persons sharing 12k now, they will have 6k each person, remainder nothing will remain. If 2 persons should share this 6k remaining here, what do you think? We'll have, if 2 persons share 6k, they'll have 33k each, and nothing will remain. Yes. We'll go again. There's still some money left. If 2 persons share 3k, what happens? They'll have 1k each person. Then 1k will remain. If 2 persons share 1k, Sam, 500 each. No, not like that. So if 2 persons share 1k, I want them to have in k, like 1k, like, yeah. If 2 persons share 1k, they will have 0. They will have 0k. The remainder of still what? 1. Yes. We'll now count up. When we count up, this pattern is something you know already. When we count up, we now have it to become 11001. It becomes that 25 in base 10 is equal to 11001. Yeah, in base 2. That's it. This method is the method you know. Although, for those doing OBJ, like those writing jam, yes. Anything OBJ, this method might waste your time. I will give you another method. It'll be faster for those doing multiple choice exam. Let's go. So pause. Now, in my second method of converting from base 10 to base 2 binary, I will teach you a method whereby you forget the remainder. You make the remainder useless. Is that clear? Yeah. But you must know one thing. You must know about even and odd numbers. I know it. I know you know it. Everyone knows it. Even numbers 2, 4, 6, 8, 10. Even numbers. Odd numbers 1, 3, 5, 7, 9. Odd numbers. Alright. So let's do this. In this method, so what we're going to do, we shall divide by 2, yes. But we shall throw away the remainders. Let's try it out. So here, 25 by 2 will give us 25 by 2 is giving us 12. Yes, like I said, throw away the remainder. 12 by 2, 6. The remainder does not concern us. Remainder does not concern us. 6 by 2, 3. 3 going by 2, 1. And that's it. When you reach 1, you stop. Yeah. You now come back and label what you have here. You are going to label odd numbers as 1, even numbers as 0. So 1 is odd, so we put 1 here. Odd, 1. Even, 0. Even, 0. Odd, 1. You count up. We have answer for 25 in base 10 to give us. Counting up, we have 11001. 11001. This method is a method of what? Forgetting the remainder. When you're done, even numbers 0, odd numbers 1. It's better for those doing OBJ question. It'll be faster. It is not calculator allowed. So next, I will show you how to move from base 10 to base 2. Sorry, who have done that already? I will show you how to move from base 2 to base 10. We'll not do other base in the next class. So quickly, let's look into converting this binary to base 10. Yeah, this is base 10. How do we achieve this? We start by labeling from left to right. 0, 1, 2, 3, 4, 5. Yeah. After that, what do we do next? This is our solution. So each of these bits shall multiply 2. Let's do this. Let's start from the first one here. We have 1. All these things here will multiply 2. 1 times 2 to what power? Power of 5. Each one you're using, you must ensure that the 2 goes to that power of that position in your place value. So this one is having 5. That's why we're using 2 to the power of what? 5. Plus 0 times 2 power of what? 4. Plus plus what? Next is 1 power of 3. So I have 1 times 2 to the power of what? 3. Sorry. To the power of what? 3. Next is 1. Right? Yes, son. Yes. We have 1. This one now will times this 2. To what power? Power of 2. Plus 0 times 2 to the power of what? 1. Plus what? 1 times 2 to what power now? Power of 0. So these two will take all these powers of labeled on top. So that's it. This is something I know you know already. Yeah. Just doing it for those who don't know to follow also. So we have here 2 power 5 is 2 times itself in 5 places. 2 times 2 times 2 times 2. 2 times 2, 4. Times 2, 8. Times 2, 16. 1, 2, 3, 4. Not complete yet. Times 2 again. So 2 in 5 places is giving us 32. Yeah. So here will be 1 times 32, which is what? 32. Plus 0 times anything is 0. It makes our work faster. 0 times anything is 0. Here, 2 power 3 means 2 times itself in 3 places, and that's 8. 1 times 8 is 8. Plus 2 power 2 means 2 times itself. That's 4. 1 times 4 is 4. Plus 0 times anything is 0. So it's out. Plus 2 power 0, anything power 0 is 1. So I have here 1 times 1. That's 1. So add all these things. 32 plus 0, 32 plus 8, 40, 44, 45. That will be 45 in base 10. That's it. Now, I will show you one more method for those doing OBJ. Any exam being OBJ, I will show you a method, a clever way of getting this thing fast without wasting time. Let's do this. So in this method, I want to make you fast. How do we do this? Anytime you want to convert from base 2 to base 10, see what you do. You start first by listing your powers of 2. What do I mean powers of 2? Watch this. Write 1 first. Now ask yourself, 1 times 2. What's the answer? 2. Yes. Go again. Ask yourself, 2 times 2. Answer, 4. 4 times 2, 8. 8 times 2, 16. Times 2, 32. Once you have this thing in your mind, all you do is take the binary given to you, place them well. This last one here, the last one here, place it here first. Next one, 0. Next one, 0. Next one, 1. Next one, 1. You see, this one self was not useful. But it's good you create your powers of 2 to a very significant point. So 32, 64, 128, 256, and thereabout. So once I'm done doing this, it's simple. All you do is, those ones that have 1 under them, you add them. The ones having 1 under them, you add them. The ones having 0 under them, you don't add them. You don't add them. So I will add the ones having 1 under them. So I'll add this one again. And this will give us 16 plus 8, 24, right? Yes, plus 1, 25. It is 10. A clever way of doing it faster without wasting time. Yeah. Now I'll show you another way of doing this. Yeah. For those writing theory, at some point I can tell you use a particular method. For instance, what we call double DAD, double addition method. Let me show you. Before I show you this double DAD method, let me show you this. What if the binary contains a decimal point? How do we achieve this? Quickly, let's run this question down. Let's do it the normal way. Fast. No, let's do it fast. We don't have time. So what do? On the left-hand side, meaning this side, we'll label it the way I showed you, which is 1. 1 times 2, 2 times 2, 4 times 2, 8. Yes. Now, on the right-hand side, that this side with our decimal place value, you do the same thing. The same thing this way, you do it this way. But this time, you are involving a fraction. 1 will stay on top of each of these things. 1 will stay on top of what each of these things. So I have here 1 over 2. Next, I will have 1 over 4. Next, I'll have 1 over 8. But there's no need. Is there a need? Yeah, there could be. 1 over 2. I don't know if you're following, Miss Soma. Are you following? I know you're lost. But I'm sure, Meso, I'm sure you are clear how we got this place. I'm sure you know how we got this one, right? Yes. Assuming the question is like this only. Like this only. What do we do? Say 1, next, 2, next, 4, next, 8. What's next? 16. We are timesing them by 2. 1 times 2, 2. 2 times 2, 4. 4 times 2, 8. For the left hand side. Since here involves decimal place, that's why it now involves fraction. Yes. Because here involves decimal place, we involve what? Fraction. After this point, that's when this side will start. The same way we got the left hand side. 1 times 2, 2 times 2 like that. 2, 4, 8, 16. The same thing here, the same thing here. Just that this hand side we put 1 on top. Are you clear now? Yes. So that's it. So next is going to be 2, 4. Here become 1 over 8. We have those 3 numbers here, 1, 2, 3. So now let's place them well. We call this thing position value method. It's the first way of moving from binary towards decimal. So let's do this. Let's place this. We place here 1, yes. We place here 0, yes. We place here 1. We place here 1. That's it. This answer will have here 101. So how do we do this? Let's place. We place 1 here. We place 0 here. We place here 1. It is very simple. Now we add. What are we adding? We are adding the ones having 1 under them. The ones having 0, we won't add them. So we have here 8 plus 4 plus 2. We will not add to 1 because there's no 1 under 2. Plus next 1. Plus next 1 over 2. Plus next 0 is there, right? We won't add this. So next add 1 over 8. That's it. So the whole number part will give us 8 plus 4 plus 1, that's 12 plus 1, that's 13. Decimal place point, this place is going to give us. So 1 over 2 will give us 0.5. Plus 1 over 8 will give us 0.125. When I add everything, we will have it that this is equal to 13.625 in base 10. That's it. Let's take one example for double dad. Yes. So quickly, I will now show you how to do double dabble method, also known as double daddy method. This method is a mental way of you getting your decimal from binary without no much stress. Just that this method cannot handle the ones having decimal. Yes. Yes. That's why I would always recommend you to use position value method when you place them where they belong to. That's the best way to solve this. However, let's just learn this for knowledge's sake. Let's convert 1, 1, 0, 1, 0, 1 in base 2 to base 10. How do we achieve this? This is just a mental way of solving. So I won't write anything down for you. Let's do it together mentally. When you are lost, you go back and replay the video. Yes, let's do this. Now, to use this double method, you simply multiply every bit here. We call these things bits. Yeah, you multiply all these bits here by these two. But each row, just watch me. Sam, watch what I will do now. I'm starting. 1 times 2. 2. Correct. I'm done with this. I'm done with this. 1 times 2. 2. 2 plus 1. 3. 3 times 2. 6. 6 plus 0, 6. 6 times 2, 12. 12 plus 1, 13. 13 times 2, 26. Plus 0, 26. Times 2, 52. Plus 1 equal to 53. In base 10 answer. We have solved it very fast. But Sam is lost. Chidinma is lost. Yes. So what do? We have to find them. I am saying that to apply this method, so what you do, when you multiply this by the base here too, you have to add the next bit. Yes. Before you multiply, add the next bit first. Add the next bit first. So 1 times 2 is 2. We'll add the next bit. 2 plus 1, 3. We'll go ahead and say, what we have now so far, after adding, you multiply again. So 3 times 2, 6. Yeah. 6 plus 0. Still 6. After adding, you multiply. So 6 times 2, 12. 12 plus 1 is out. 13. 13 times 2, 26. 26 plus 0. 26 times 2, 52 plus 1. That is 53 answer. If this method will complicate things for you, gradually, manually, use your normal position value method. So quickly, we look into the order first. No need of showing you order basis, because the same process for moving from base 2 to base 10, the same process for moving from base 3 to base 10, the same process. So once again, this is Nolestra, and I am Horget Emmanuel. Thank you for watching. Please like the video.